Okay, geometry students, this is our next new section. This is 10.2. Again, I want to reiterate, this is voluntary. Okay, this is not for a grade in the grade book for geometry, but some of you guys, particularly if you want to score well on the ACT test, are going to want to be able to look at some of this material. There are lots of circle things and geometry stuff in general on the ACT test, so I want to make sure that I at least give you guys the opportunity. I hope these videos are helpful. So let's go over the geometry study guide here. So the vocab, we are talking today about central angles. Okay, the central angle of a circle is an angle whose vertex is the center of the circle. Okay, a semicircle, I think most everybody probably knows. It's a half circle. It's an arc with the endpoints that are the endpoints of the diameter. So if we have a circle, okay, if this is my center, this would be a central angle, and the central angle is the same measure as the arc length. We're going to get there in just a minute. But a semicircle, actually let me do it in blue, a semicircle is if I have a diameter that, again, remember diameters are chords with endpoints on the circles, but they have to go through the center of the circle, then this would be a semicircle, okay? This arc in here, and we all know a semicircle is 180 degrees, it's half a circle, okay? Now, if measure of angle ACB is less than 180, then the points on circle C that lie in the interior of angle ACB form a minor arc. So minor arcs, okay, are less than 180. This would be your minor arc here, okay? It's less than 180 with endpoints A and B. The points on circle C that do not lie on the minor arc AB form a major arc with the endpoints at AB. Okay, so minor arc, first of all, here's how we would write it. We would write AB with literally a little arc, a little arch kind of above it. Okay, a major arc is going to be greater than 180. So this would be a major arc. And typically, a major arc is denoted by 3 letters because it kind of helps to know where the middle is, so you know like what direction you're going around the circle. So this would be, the major arc would be arc ADB with a little arch above it. Okay, so major arc, minor arc less than 180, major arc greater than 180. Major arcs and semicircles usually have 3 letters that define them. Okay, so you know kind of what direction you're going. Now it says the measure of a minor arc is the measure of its central angle, and that's what I alluded to earlier. So measure of a minor arc is the measure of its central angle. That means, in this one up here, if I said this was 80 degrees, let me label these points. Let me say this is D, E, F, okay? Then I would say the measure of arc ED was also 80 degrees. The measure of the arc is the same as the measure of the central angle. Okay? And I don't really like this definition, but it says the measure of a major arc is the difference between 360 and the measure of the related minor arc. So I don't know why they can't just say it's the measure of the other angle, but whatever. So if I were measuring back on my example that I had here, let me use purple again. If I were measuring arc, let's see, DFE. Now, DFE, I'm going to outline it here. I hope you all can see the purple. DFE would be this arc. Okay, so what they're saying here by the definition, if it's the difference between 360 and the measure of the related minor arc. The minor arc ED we just found to be 80, so the measure of DFE would be, sorry, I don't know what I was getting ready to write, 360 minus 80, 280. Okay, I hope that makes sense. Okay, so the measure of the arcs are the same essentially as the central angles. Postulate 23, the arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. This is nothing new. We've had the segment addition postulate. We've had the angle addition postulate. If two things are adjacent, they're side by side, you get the measure of the total by adding them up. That's nothing new. Okay. Congruent circles. This is a big one. Congruent circles are two circles with the same radius. Okay, they don't necessarily have to lie on top of each other and be the exact same circle, but they do have to have the same radius. And then congruent arcs. Congruent arcs are two arcs with the same measure that are arcs of the same circle. Okay, so they have to, and actually I should go or congruent circles. I'm not sure what I was trying to do there under the or. I was trying to emphasize it. So congruent arcs are two arcs with the same measure that are arcs of the same circle or congruent circles. Okay. So for instance, on that one, if I had this circle and I had this circle, and my drawing leaves a lot to be desired, but I said this radius was 5 and this radius was 5. And then I told you, let's see, this is A, this is B, this is C, this is D. I told you that this measure was 70 degrees and this measure was 70 degrees. Okay, does the measure of arc CD, is it congruent? Actually, I didn't leave room for my congruent sign. Well, I was doing measure, so it actually would be equal. The measure of arc CD equal to the measure of arc AB? That would be a yes. Okay, they're not necessarily on the same circle, but the central angles are the same, which means the arc measures are the same, and they are on circles with the same radius. Okay, so that would be a yes. The measure of arc CD is equal to the measure of arc AB. Or again, you could say that the other way, that CD arc is congruent to AB. Remember the difference between congruent and equals. We use congruent when we're relating to geometrical shapes, like segments or circles or triangles or whatever. We use equal when we're talking about actual numbers, measures of those things. Okay, so let's look down here real quick. Example 1, find the measure of each arc of circle J where Km is the diameter. Okay, so LM, they only use 2 letters to name it, so that's that arc. Okay, that's 125 degrees, obviously. Okay, LMK, now they used 3 letters, so that's a major arc. So that starts at L, goes around over M, and up to K. All right, well, how can we figure that out? Well, we know if Km is a diameter, then the semicircle is 180. So 180 minus 25. Okay, well, there's a couple different ways you can do it, I guess. Actually, the easiest way that I see they did it here, just 180 is the semicircle. Okay, and then plus 125. So this is, of course, 180 degrees. I was going to do 360 minus, 55, but either way. Km is a diameter. Oh, so now we're doing KLM, sorry. So KLM, we're starting at K, we go around L, and we end at M. Okay, KLM is a semicircle, so it's 180 degrees. Okay, so let's look at some of these ourselves. Okay, identify the given arc as a major arc, a minor arc, or a semicircle and find the measure of it. Okay, so arc AD, we're looking at this one. Major or minor? Well, it's less than 180, so it's going to be a minor, and it is 70 degrees. Okay, AB, this one right here, well, again, less than 180, so it's also a minor. And what would its degree measure be? Well, it looks like CD is the diameter. So if AD is 70 and BC is 50, 70 and 50 is 120. That has to add up to 180. So this would have to be 60. Okay. I hope that makes sense. Now, arc CD. Okay. Arc CD, couple different ways you could draw it. This is a semicircle. Now, semicircles are kind of interesting because they technically aren't major or minor, but they can be named with either 2 characters, 2 letters, or 3 letters. So where typically a minor arc is named with 2 letters and a major arc is named with 3, a semicircle could go either way. I've seen it done both ways. So semicircle, of course, we know is 180 degrees. Okay, BDC. Now, BDC, again, you have to be careful of the placement. You have to go from B to C, but crossing D. So you're starting here, you're going around D, and you're going to end up at C. Okay, that, of course, is a major arc. Okay, again, it's also named with 3 characters, so that was kind of a giveaway. And the measure of that is going to be 360 minus 50, because you just have to subtract the BC arc. So 310 degrees. I hope you see that. The next one, ACD. Now ACD, you are going around this way. You have to go through C, then around to get to D. Okay, so ACD, also a major arc. Again, dead giveaway that it was named with 3 letters. And then 360 minus 70 would mean it's got to be 290. Okay, and then BC. BC is little. BC is the only one we haven't done yet. BC here is minor, of course, and it is 50 degrees. Because remember, the arc measure is the same as the central angle. Okay. All right. Backside. Yeah, you can look through that example too. I'm not going to take time. It's going into the angle addition postulate. Again, if you're adding different segments, different central angles to get a whole, you add them together. I don't know that we necessarily need to go through that. We're going to do some examples here on exercises here 7 through 12. So find the measure of the arc AED. Now, AED, again, this is a semicircle, right? And just like I said earlier, the semicircle on the front page was just named with 2 letters. This one's named with 3, so you got to be careful. But it's semicircle, so of course it is 180. It's 70 plus 110. So therefore, we know that AD has to be the diameter, right? AC, if we do AC here, AC, because it was just used with 2 letters, it's got to be the minor arc. So what we have to do is try to figure out if this is 70 plus 35 is 105, what are we missing to get to 180? We're missing 75 degrees, right? So 75 plus 35 is 110. I hope you guys see that. ACE. Now, ACE is a major arc, and again, we got to go around the circle in kind of that direction so you can see it. A, you have to go through C and then around to E. So it's essentially a whole circle minus the 70 degree, the only part that isn't outlined in blue there. So 360 minus 70 is going to be 290, major. BE, okay, BE. Let's go back to purple here. BE, because it was just named with 2, is just the minor arc, so it's got to go around this way. So 70 plus 75 is 145. CDE, so CDE is this one. Again, it's named with 3, but it really is a semicircle, right? It's half of it, so that's 180. And then AEC, I'm covering up all my stuff here. AEC, this, so AEC, we start here and we go around over to here. So really we are taking 360 minus the 75 plus 35, okay, which is 110. So that's going to leave us with 250. I hope that makes sense. Okay. All right. Now, congruent arcs. Okay. Remember, congruent arcs have to have, let me write this up here. Congruent arcs they must have the same angle measure and come from same or congruent circles. Okay, congruent arcs must have the same angle measure and come from the same or congruent circles. So 13 and 14, tell whether the highlighted arcs are congruent. Well, you can kind of see the darkened lines here. This one, which is 180, that's a semicircle, and this one is 180, that's a semicircle. So they fit the same arc measure, but do they come from circles with the same radius? Obviously not. So this is a big fat no, okay? And the reason is circles are not congruent, okay? Circles are not congruent. That's why they have the same arc measure, but they don't come from circles with the same radius, okay? Last one here. Again, highlighted. We're looking at this arc versus this arc. Now, looks like both of them have a 135-degree arc measure. Do they come from the same or congruent circles? And actually they do. If you notice here, this radius is the same for both circles. Okay, the circles overlap to where they share the same radius. So this is a yes. Okay, they have the same arc measure and congruent circles. Okay, same arc measure and congruent circles. That's what I would say. Okay, let's dive into the practice A. I don't think this section is just too terribly hard. Practice A here. Name the arc shown in bold. Okay, well, here's the arc in bold. Okay, that is just a minor arc, so we could get by with just 2 letters, and we just put the little arch kind of above it. Okay, so arc AB. I'm just going to do one more here. The next one only because it's a major. So the one that's outlined here in bold is this one. So that would be arc ADB, or you could name it BDA. Doesn't matter. Either one of those 2 would work. But you got to have the D in the middle. Remember, major arcs, if they're over 180 degrees, have to use 3 letters, and they have to go in order around the circle. Okay. Let's jump down to the next section here. AB and FE are diameters of circle C. Determine whether the given arc is minor, major, or semicircle. So technically, just by the way they're named, you ought to be able to tell. However, if you remember, the semicircles can go either way. They can use 2 letters or they can use 3 letters. So you really have to look at them. So AE, obviously, AE from here to here is going to be a minor, right? FDE. Let's look at FDE. FDE has to be this, Okay, that's a semi. That looked a little sloppy, but you get the idea. Let's jump over number 7 because it also has 3 in it. DFB. Let's see, DFB would have to start here, go through F, and then end at B. That obviously is a major. Okay, so that's what you're doing there, just labeling. The next section, in circle O, MQ and NR are diameters. Find the indicated measure. So remember, see the little M right in front of it? That means they want the actual angle measure, which remember, the arc measure is the same as the central angle. Okay, so measure of MN, for instance, MN here, this arc measure is the same as this central angle. So that is going to be 70 degrees. Measure of NQR. So NQR, that is this. Well, they told us up above that NR was a diameter, so that has to be a semicircle, makes it 180 degrees. Jumping down, let's look at 18, QMR. QMR. So we start at Q, we go around to M and then R. So we start here, we go around to M and then end in R. Wow. Okay. Now, how could I figure that out? Well, a couple of different ways, but we know that if this is a diameter, NR is a diameter, then we know that this has to be 110 degrees, right? Because 70 plus 110 would give me my 180. So we could do from here to here is 180, and then plus 110. Okay, so this is 180 plus 110 gives me 290 degrees. That's where that comes from. Okay, I hope you guys can see that. Okay, I'm going to move on here. Find the indicated arc measure. So the measure of arc AB, well, they gave us enough information here. With this is perpendicular, that means it has to be 90 degrees, because remember the arc measure is the same as the central angle. 23, measure of arc ACB. So we're looking at this one, ACB, the major. Well, if this is 90 degrees, then that's going to be 360 minus 90. So that is 270 degrees. Okay, and so on. Okay, next page. It says, use the information given about the central angle of a circle to find the measure of its corresponding arc. I think you guys can do that. Because remember the corresponding arc is the same as the central angle. So you guys got that section. Tell whether arc AB is congruent to arc CD. Well, this first one, arc AB, is that going to be congruent to arc CD? Yes or no, and why? Well, I say yes because these are actually vertical angles, right? So I would say vertical angles are congruent, so their resulting arcs are congruent. Okay, 31. Let's look at it. Now, we've got this AB and this CD. They're both 65 degrees, but are the arcs congruent? Yes or no? I would say no. Okay, the reason being they have the same arc measure, but different radii lengths. Now, believe it or not, the plural of radius is radii, R-A-D-I-I. Or it actually, you can also do radiuses. So you can just write radius with an ES on the end. But I actually looked this up. I remembered that, and then I thought, really? So I looked it up to make sure, and that is true. Radii is plural for radius. More than one radius. Okay, so same arc measure, but different radiuses. Oh, goodness. You all get the idea. Now this one I like. Keeping time in the clock face shown at the right, the positions of the numbers determine congruent arcs along the circle. So what is the measure of the arc between any two consecutive numbers? Now, here's what I kind of like to do. If I draw my XY axis, then I know each one of these is 90 degrees, right? So to cut that into 3 equal parts, that means each of them would have to be 30. I hope that makes sense. Okay, between any two consecutive numbers. Again, these are all 90 degrees, right? Let me jump down. Number 35, starting at the number 2, what number does the end of the second hand reach as it completes a semicircle? So if we start here at 2 and we go around 180 degrees, half the circle, that would be like radius. It would end at 8. So I think that's kind of a fun exercise, but you guys can try these, okay? Again, not for a grade, but just as a practice, get your brain moving, and you can use these. A lot of this will show up again on the ACT. So, okay, hope this helped, guys. Miss you all and anxious to see you again sometime.